Okay, so recording this video about David Lippman's and Melanie Rasmussen's section 1.1, give you some, like, what are the highlights of this? You can, certainly should thumb through the book and look at it. And then, of course, each MyOpen Math exercise has a video with it, so, use those. But sometimes people like an overview of it all, so I'm going to try that this semester, create these new ones for you, and hopefully it helps. So here's the important topics, the learning targets will you have for section 1.1, and I'm hoping a lot of this is review from Algebra 2 or college algebra. And what's a function really? Well, a function, remember, is, let's see, can I zoom in? Yes, I can. So a function really is just, it has an input and output, and back in elementary school or middle school, you might have seen this. Here's an input output box, right? We drop stuff in and get output out. And when a relationship is a function, each input uh, only gives one output, and that's not to say um, it's unique. I mean, then the output's unique because it can still be a function and have one x and one y can have two different x's. What I'm trying to say. Okay, so what's the function? Where do people use this? Well, this is one place where this affects all of us if you're working for wages. Um, so when they figure out your tax, your income tax and what you earn each week, I mean, this is all done with software for the most part. You look at your gross pay, and if your gross pay falls between 765 and less than 775, you're going to have to pay. Well, let's see. Most of you are probably single, so you'd keep they'd keep $56 for federal tax for Joe Biden and the Congress to help pay for things. And notice that less than 75. See, what if you earn exactly $775 in your paycheck for your gross pay? Well, you don't want it. Which tax do you pay? Do you pay the 56? Do you pay the 57? Well, they kick it up to the next notch. So that's what it means when you go to the next tax bracket, right? Overtime does this. So that's why that's what makes this tax table a function, because 775 only has one output. It's 57 bucks. If you're in 774, well, then you're down at 56. So you see how one input only gives one output. So I can't get two outputs. Okay, so that's what makes the function a function. So let's say, I guess, that's the so what. And there's many other applications. Let's just roll on down the road and look at some examples here. One thing I want to point you out on page 11 of this is that 2.3 version of the textbook. If you get an old version, you'll have to find it's in section 1.1. They don't change the sections up too much, just some of the extra stuff they add in. But the exercises are the same, and the notes are pretty much the same. But these toolkit functions are something you want to at least make sure you're familiar with, and you probably have seen them all before in earlier classes. Um, here I'm assuming you know them. You can recognize the graphs. So on page 11, they give you the definitions and what the functions kind of look like. And page 12, they give you some graphs. So take a look at those and maybe put a bookmark in your book if you have a bookmark, or bookmark the PDF so you can flip back to them if you need them. They're important. We want to know how part of pre-calculus is figuring out, getting you very familiar with how functions behave. Um, so, I mean, if I know parabolas x squared, we know have a vertex, every turning point. We know that x to the third functions, that they look like, they go this way, and there's might be some wiggles in the middle. There might be nothing in the middle. Well, they don't have x to the fourth as a toolkit function. We got to know that 1 over x behaves like this. It has a vertical asymptote at x equals 0. We need to know that the reciprocal squared function heads off in the same direction. So they look like that. They have a vertical asymptote at x equals 0, because I can't divide by 0. Okay, so check that out. Make sure you remind yourself of that stuff. So functions can be defined as tables. It can be defined in English. It can be defined as graphs. And but what we got to always keep in mind is that each x only gives me one y. I can't have one x giving me two different y's. That's not to say, as I said, that I can't have an x here, a different x here, and a different x here. I'm going to label this x sub 1 and x sub 2. That doesn't mean those can't both give me the same y and not be and fail the function test. That can be a function also. So let's look at it. And when you're given a graph, the easiest way is to think about the vertical line test. If you drop a vertical line through the function, does it ever cross it more than once? Well, that doesn't. So, yep, a is a function. Is this squiggly? Actually, it's a cubic function. Does that pass the vertical line test? Yep. Does this pass the vertical line test? It does here, but it doesn't here. Okay, so because of that, part C is not a function. Part D, or question D does, passes. Part E does, passes. This circle does not. That's not a function. So let's see. This is not a function. This is not a function, but everything else is. Okay. Now, one other thing that comes up with this, and it kind of alludes to this, functions can be one-to-one, which when a function is one-to-one, that means each x is paired to exactly one y, and each y is paired to exactly one x. I can't have, well, let's look at this graph, okay? Just a minute. Okay, so this, if the function's one-to-one, that means that, so I said that each x is paired to only one y, so this situation would not be one-to-one, okay? So in this case, we're going to use graphically, we're going to use the horizontal line test. Just like the vertical line test, if it crosses the graph more than once, it's not one-to-one. So this horizontal line, not one-to-one, because y is always 2 in that case. So not one-to-one. Is this one one-to-one? No, it's not, because it crosses. I've got multiple x's giving me the same y, so not one-to-one. Now this is one-to-one, but it's not a function. So in order to be a one-to-one function, it has to pass the vertical line test. X's can't repeat, and it has to pass a horizontal line test. So if it's not a function, we can rule it out. Yes, a function, but not one-to-one. Yes, a function, but yes, it is one-to-one. Not a function, it's not one-to-one either. Okay, so that's when we're looking at a graph. So we use the vertical line test to check for functions, and we use the horizontal line test to check for one-to-one functions. Okay, alrighty. So when they give us to these things as tables, remember how if it was a vertical line test, it couldn't cross the graph. Here, let me do something weird like this. It couldn't cross the graph twice, so x's can't repeat, right? This x, so if x equals 1, if x equals 1 and y equals -3, and x equals 1 and y equals 5, well, this relationship is not a function because the x's are repeating. The x gives me 2 different y's. So when they give you a table, check and see if the x's repeat. If the x's only occur once, it's a function. Hey, 5, 10, 15, it's a function. So yes, actually, I should check it. Here, again, 5, 10, 15, x's don't repeat. The y's do, but remember when the y's repeat, that's a one-to-one issue. So yes, that's a function. See here how the 10 repeats and 10, so I'm getting the points 10, 8, and I'm also getting the point 10, 14, not a function. Okay. Now the one-to-one, remember what I just said? It's got to pass the rule for a function. The x's can't repeat, and if it's not one-to-one, then y's can't repeat for 2 different x's. So here, see how the y's are repeating? Is a function. The x's don't repeat, but we have 8, 7, and 7 and 12, 7. So not one-to-one. Here, the x's aren't repeating, the y's are not repeating. That's a one-to-one function. Here, it's not even a function, right? Because the x's are repeating. So check for repeating x's, not a function. Repeating y's, not one-to-one. Okay. So let me stop it for a minute. So now how do I evaluate functions? So when I see f of 1, that's basically asking me, I'm hoping this is familiar, that's asking me what is y, or the output, when x equals 1. So for this graph, they gave me a graph. Well, I see x equals 1 here. Let me zoom in a little bit so I can see it. When x equals 1, let me get a pointer going. When x equals 1, I find x1 on the x-axis, I go up till I hit the graph, and then I come over to the y. So f of 1 is 1. What is f of 0? F of 1 equals 1. What's f of 0? They didn't ask me this, but what's f of 0? Well, I'm gonna go to x equals 0, go down till I hit the graph, and this is on the y-axis, so that's -1 or -2. That easy, okay? What if they ask me something like this? So that, hey, here's this function g. This is some g function, and they're asking me what's g of 2? Well, that's when x equals 2, what's y? And this is just what I did up above. You come up and find 2 on the x, you go up to hit the graph, and you slide over to 4. So the y is 4. When x equals 2, y equals 4. So that answer is 4. This is asking me, what's x when y equals 2? So what you're going to do in this case is you're going to find y equals 2, go over till you hit the graph, and it may happen in more than one place. In that case, it wouldn't be 1 to 1, would it? And this is going to be -3. So when x equals -3, y equals -2. Okay, pretty easy. Then we're going to do the same thing with a table. Well, this says when x equals 3, what's y? So here's x, here's 3. What's y? 53. This says when y equals 1, what's x? So we're going to scan across the y values, the f of x values, and I see only one place that happens. So that answer is 2. So this is going to be, what did I say? This is going to be 53, and this is going to be 2. So one last thing about, before I leave this table, and this table doesn't have that. On the first exam, I'm going to ask you a question like this. I'm going to give you a table of values, and I'm going to ask you to, or I might even give it a graph. But anyways, I'm going to give you a table, and it's not going to be a one-to-one function. So say I have like a 10, and I've got another 1 here. Okay, so in that case, I'm going to say use the table to evaluate these expressions. So what you got to worry about is, if x equals 2, y equals 1, see how x equals 10, y equals 1. So you got to make sure you identify both of those situations. And again, that only occurs when your y's are repeating. It's not a one-to-one, function. Okay. Okay. Last couple of pieces. When they give us a situation like this, is saying what's f of -1 plus f of +1. What you've got to do is you got to substitute in the equation, right? So -1 squared, so f of -1, right? That's what I'm doing. F of -1. Why did I write f of -x? F of -1 is you're going to substitute -1 and drop it in the equation. Drop it and replace the x's with now you notice how I'm replacing the variable with parentheses. This is a good habit to get into, because when I square -1, I get +1, and then 8 times -1 is -8, and -4. So that answer is actually going to be what? That'd be -12. So 1 minus 12 is -11. What'll happen if you're using a calculator and you do -1 and then hit the x squared button, that's going to treat it as -1 times 1 times 1. Okay. For example, if it was f of -2, like this one. So if you were the correct way to do it is to say -2 squared plus -2 plus 3, and that way when you -2 times -2 is +4, -2 plus 3, that's 5. But if you type that into a calculator and do -2 squared, that's going to treat it as -1 times 2 times 2, when the calculator will give you -4, not the correct +4. So using the parentheses will help you from keep you from making mistakes. So there's that. And then then what you do for the second piece of this, you just drop in 1 into the equation. So it's going to be 1 squared plus 8 times 1 minus 4. What is that? 5. So then what you do to finish answering this question, we know that this is -11. We know that this is 5. We add those two results together and we get -6. Okay, so algebra with functions, expressions. That's all that's all about. And if you're going to replace it, I guess maybe I should do this one. They're telling us evaluate f of 0. See, it's the same thing as with a graph, except now what we're going to do is this is the y, so we're going to replace f of t with 0 because that's what they're looking for. So 0 equals 3t plus 5. Subtract 5 from both sides. This is like algebra 1 kind of stuff, right? T equals negative 5/3. It's an important idea, though, solving where the function's equal to 0. Last thing in this section, and this is just a little thing. What's the equation of a circle? Okay, so the equation of a circle is going to be x. This is the general form they show us in the book. X minus h squared plus y minus k squared equals r squared, where hk is the center of the circle. The x is h, the y is k. I don't know why they use h and k. And of course, r equals the radius. So for this circle, here's my h, here's my k. That's my x and my y, and I just drop those right in the formula. Minus 3 plus y minus 9, but minus a minus turns to plus, right? And then we're going to square 6 and get 36. It's perfectly acceptable to write it 6 squared. You could also write 36, okay? So watch your signs and don't do any more work with it. Don't expand it out. You don't need to do that. Okay, that's 1-1. Go get it done.